Oh, lovely. All our grade sevens back with us. Hello, Tamisho, Tumelo, Yandi Sambuli. I don't remember seeing you last time, so I don't know if you're new to us, but welcome if you are. Alwetu, nice to have you back again. Please get started on the do now. Lindiwe and Jenna, Esther, thanks for joining us. Please get started on the do now. This is based on what we were talking about on Tuesday. Okay, so we should be able to carry on going from there. Chiamo, welcome. So nice to have you all with us again. I so look forward to these lessons with you guys. Okay, so for those of you that have just joined us, please try the do now. This is based on what we were talking about the last time. So hopefully everybody is able to do these questions without too much difficulty. Hello, Trevor. Nice to have you back with us. And Theo, thank you for coming and joining us again. Okay, so everybody that's just joined us, welcome back. We're trying the do now. We're going to see if we can do those 4 questions. This is on multiplying and dividing fractions, which is what we were talking about the last time. Yandi Sambuli. Well, hi there. Nice to meet you. I don't think I remember you from last time, so I don't know if you've just joined us, but welcome to our lessons.
Mute. Do now.
Hi, grade 7s. Welcome to our 4th lesson of fractions. To all the new learners, welcome. Please make sure your name is your own and not your parents or someone else's. Simply rename or ask me for help. Okay.
Thank you for reading that for us, Yandi.
So beautifully read as well.
Thank you, ma'am.
Is Yandi, are you new to grade? Are you new to these lessons, Yandi?
Yes, ma'am, I'm new.
Oh, okay. Welcome, welcome. So nice to have you with us.
Ma'am, don't worry. I saw the last sessions last week, Tuesday, so I'm all filled up with the Watobe lessons about fractions. Yes, ma'am.
Oh, good. I'm so glad. Thank you for all that positive feedback. And we're really, really pleased that you decided to join us. So that's great news. Okay,
while
great.
you're all busy with the, sorry, do you now?
Sorry, why did we
I just
decide to
wanna-
talk at the same time?
No, I just want to say that sorry, I muted you quickly, Yandi. So whenever you want to give an answer or maybe ask a question to Lee, please feel free to unmute yourself, and then after you've finished your question, you can just mute yourself again. Okay?
Oh, okay. Sorry, ma'am. I didn't understand. So say thank
No,
you.
that's no problem. Thank you. Okay, Lee. I'm giving
Okay,
it over to
thanks,
you. Enjoy.
Alzan. Thank you. Yeah, it just seems to sort of work better if we keep ourselves on mute unless we want to ask a question, because often sometimes, we've got brothers or sisters around us or our parents or other people making a noise. So that's why we just stay on mute, but you're very welcome to unmute yourself anytime you like. I don't mind you stopping me at any stage and asking me a question. Okay, and that's the same for everybody, not a problem at all. Okay, so now over to you guys. I'm going to ask some people for some answers, all right? And if you didn't manage to do it, it's not the end of the world. It never is. We can do it together. All right, so Tumelo, what did you get for number 1? So either you can unmute yourself or you can pop it into the chat, Tumelo.
9 times 5. 9 over 5.
9 over 5, Tumelo. Okay, I got 9 over 20. Did you remember to multiply 5 by 4 at the bottom? Remember when we're multiplying fractions, we're multiplying numerator with numerator and denominator with denominator? So it would have been 3 times 3, which is 9 in the numerator, and 5 times 4, which would have been 20 at the bottom.
Yes.
Okay, all right, Tumelo. Theo, can I call on you to do number 2? Can you tell us what you got for number 2, please, Theo?
Yes, ma'am.
Thank you.
4 over 3, ma'am.
4 over 3. Let's have a look. Hey, well done. That's great, Theo. Excellent. Good job. Okay,
Thank you,
so now I'm going to call on Tamisha.
Yes, ma'am.
Tamisha, thank you, Tamisha. What did you get for number 3, please, Tamisha?
Ma'am, I got 3 over 20.
Hey, so sharp. Well done. That's excellent. Sure, you guys are doing so well. You don't even need me as a teacher anymore. Hey, you're so clever. Excellent. Good job. Okay, and then Baja, I'm going to call on you. What did you get for number 4, please, Baja?
I got 1 over 2.
You got 1 over 2. Okay, I didn't get 1 over 2. I got 5 over 6. How did you get 1 over 2? I wonder. Okay, so what we were supposed to do in number 4, if you recall from last time, when we're dividing fractions by do you remember what the rule is? We've got to tip in times or keep, flip, change. Okay, so 1 over 3 is the fraction that we are operating on. We're going to flip the sign. So we're going to change divide into times, and we're going to flip the fraction that follows. Okay, so the 5 has to go to the top, the 2 has to go to the bottom, and then remember we follow our normal rules for multiplying. So numerator with numerator, so 1 times 5 is 5, and denominator with denominator, so 3 times 2 is 6. I'm not sure where you got 1 over 2 from, but because you can't cancel the 3 and the 5. These 2 can't be cancelled because they're not the same value. Okay, does that make sense, Baja? And everybody else? Any questions? Everybody happy? Thumbs ups?
Yes, ma'am.
Okay, thanks, Tumelo. All right, so tonight we are going to be cool, Trevor. Thank you. All right, so tonight we're going to be talking about adding and subtracting fractions, okay? And that's why I've left it to this 3rd or 4th lesson that we're having, because I think that adding and subtracting fractions is actually more difficult than multiplying and dividing, all right? So we need to, when we are working and we can see that we're working with fractions, we've got to speak to ourselves inside our head, and we've got to say, what am I doing, all right? Because the operation that you are using will dictate or tell you what method you have to use. So if a question has got multiplying fractions in it, then you have to do what we've done before, multiply numerator with numerator and denominator with denominator. If we are dividing, we have to know the rule for dividing so that we remember to keep flip change or tip and times, right? When we add and subtract, what's the rule for adding and subtracting fractions? Can anybody tell me before I tell you? How do we add and subtract fractions?
Ma'am, we need to change the denominator to be the
Okay.
same denominator.
That's it, Trevor. You put that so well. Okay, so did everybody hear what Trevor said? Right, he says we've got to make sure that the denominators are the same. Okay, so remember our denominator tells us how many pieces our whole has been cut into. All right, and that's why when we add them together, we've got to have the same denominator. Our whole needs to be cut into the same number of pieces because we can't add together fractions if the denominators are different. All right, so sometimes it's super easy like it is in the first one because 2 goes into 4, right? 4 would be our lowest common denominator because 4 is in the 2 times table and 4 is in its own times table. So 4 times 1 would give us 4 and 2 times 2 would give us 4. All right, so what we're going to do is this. Sorry, let me just move the chat out the way and get a pen. Okay, so the first thing that we look at grade 7s is not the numbers. The first thing that we look at always is the operation. Okay, so check to see what the operation is and then decide on the correct method. Okay, so here we can see that we are adding. We know we've got to have a lowest common denominator. So what we're going to do is we're going to use 4 because 2 goes into 4 and 4 goes into itself. So essentially by multiplying the denominator by 2 and the top by 2, I am creating an equivalent fraction. Remember our first lesson on equivalent fractions. So they have the same value, but the numerators and the denominators are different. So this would end up being 2 over 4 plus 1 over 4. And when I add them together, I'm going to keep my denominator. So I'm going to keep the 4 and I'm going to add the numerators together. 2 plus 1 would leave me with 3. How does that feel? Easy enough?
Yes, ma'am.
Yes, ma'am.
Okie doke.
Yes.
All right.
Ma'am.
Yes, ma'am.
Okay. So grade 7s, you try number 2 by yourselves. And I'm going to give you 2 minutes, and then we'll talk about what you got as an answer. Wow, Trevor, awesome. Well done. Aisha, you also done. Excellent. Good job. Oh, we've got Njabulo with us again. Cool beans. Uko. Oh, so nice, guys. That's lovely. Good job. Okay, so Uko, I'm going to call on you. What did you get as your answer for this question, Uko?
Ma'am, I've got 11 over 15.
11 over 15. Okay, so who agrees with Uko that the answer is 11 over 15?
Yes, ma'am.
Okay, Jenna, good job. All right, so 11 over 15, I quite agree. Let's just do that quickly together. Well done, Uko, that's perfect. Good job. All right, so just very quickly, we would have seen that 3 goes into 15 and 15 goes into 15. So times by 5 times by 5. So that would have given us 10 over 15 plus 1 over 15, and that's where the 11 over 15 came from that Uko got. Okay, good job, well done. All right, so if everybody got that, that's really nice. Let's go and have a look at the same idea, only now, whoopsie daisy, only now we are subtracting. Okay, so let's try that. The rules are exactly the same for subtracting fractions as they are for adding, so that denominators have to be the same. All right, now, what number is that? I think that's supposed to be a 1. Sorry, grade 7s, I didn't write that very well, did I? Let me go and change it. Okay, I know it's a different color, but anyway, it doesn't matter. All right, so again, the first thing that we look at is the operation. Okay, look at the operation first, all right, because you need to know, am I multiplying, dividing, subtracting, or adding? And that's going to tell me how to proceed. So I can see that I'm subtracting. Again, I can't subtract fractions if the denominators are different. So now I need to find an LCD. Who can tell me what LCD I should use in this case? Let's see who I can. Yandi, do you know what should our LCD be?
I beg your pardon, ma'am.
No, I'm just asking if you know what our lowest common denominator should be in the case of question number 3. Is there an idea that you have? Which number would you use?
3.
3. Okay, but 3 goes into 3, but does 7 go into 3?
No, ma'am.
No, it doesn't. Okay, so who can help Yandi? We need to find a lowest common denominator here. And Jabulo, what would you use?
Ma'am, I think 1 or 2.
As a lowest common denominator. Okay, so Jabulo, your lowest common denominator has to be a number that 7 goes into and 3 goes into.
It's 1, ma'am.
I got it.
Okay, so it's unfortunately it can't be 1. Both 1 goes into both of those numbers, but they don't go into 1. Somebody else said something?
Ma'am, is it 4?
Stembiso, that is a very good suggestion, but that is the difference between 7 and 3. What we've got to do is we've got to create an equivalent fraction with 5 over 7 and 3. Okay, so the first thing that we have to do is we have to look at the operation. We're minusing, okay? So we need a lowest common denominator. Often what's easiest here is for you to multiply these two numbers together, because 7 times 3 will leave us with 21. So that means we can make 5 over 7 into something out of 21, and we can make 1 out of 3 into something out of 21. Okay, so what am I going to multiply 7 by to get 21? I've got to multiply it by
3.
3, indeed, Theo. And Theo, when I multiply the bottom by 3, what do I have to do to the top?
Multiply by 3 also.
Indeed. Okay, so whatever I do to the denominator, I've got to do the same thing to the numerator. So if I make the denominator 3 times bigger, I've got to make the numerator 3 times bigger. Okay, so now that I'm multiplying 5 by 3, what number, Yandi, am I going to have in the numerator now?
Sorry, ma'am.
What number am I going to have in the numerator now, Yandi? 5 times 3 is going to leave me with what at the top?
50.
Good, well done. It's going to leave me with 15. Okay, and now I'm going to call on Akila. All right, so Akila, what am I multiplying 3 by to get 21?
7.
By 7, good. Okay, so if I multiply the bottom by 7, I have to multiply the top by 7 as well. Okay, good job. Okay, all right. So, sorry, I wasn't looking at the chat. Yes, Uko, 21 was the right thing. Mapalo, you said 15. That's great. Well done. All right. So now I've got 7 at the top. Right, and now it's the same thing. I didn't really leave very much space here to write. That wasn't very smart of me. Let me just make a little bit more room. Get rid of that. Okay, and now I have to keep the same denominator. Okay, so I'm going to keep the denominator of 21, and Mapalo says the final answer should be 8. Good job, Mapalo, 100%. Well done. Okay, so 15 minus 7 leaves us with 8 at the top. Good job. Okay, so now grade 7s, are there any questions?
No, ma'am.
Sure, okay. All right, you try number 4 on your own. And I'm going to give you 2 minutes to do that. Oh, Anel, I wonder why your mic isn't working. Okay, don't worry, Anel. You can pop your answers into the chat. All right, it's not a problem. Okay, Aisha, you're already done. Wow. Speedy Gonzalez, aren't you? That's great. So if you want to ask something, just pop it in the chat, Anel. It's no problem. I'll keep my eye on the chat as well.
Done, ma'am.
It's common.
Well done, Jabulo. Uko, are you also finished?
Yes, ma'am.
Okay, lovely. Well done.
Ma'am, I'm done.
Well done, Stembiso.
Ma'am, I'm done.
Excellent. Theo,
Yes, ma'am.
are you finished?
Yes, ma'am.
Okay. All right. So Theo, tell me, what did you do here?
I times 8 by 16. Then
8 by? Did you times 8 by 16?
I got 128 and 350. And times
Okay.
3, and I got 20.
Okay.
And I got
And then what was your final answer, Theo? Shame, Theo, your mic is breaking up a little bit. Can you say that again, please? And I think we might have lost. Mapalo says times by 2. Absolutely, Mapalo. That's exactly what I would have done here. I wouldn't worry about working with big numbers. So after you have checked that you are, which operation you are using, so we know that we're minusing, have a look at the denominators. Yes, Yandi, go for it. What would you do?
Ma'am, I said 8 times 16, and also in my, I think it's numerator, 7 times 16. Then on the 3 over 16, I said 16 times 8, 3 times 8. Then for my 7 over 8 times 16 gave me 112 over 128 minus 24 minus 128. Then my final answer is 88 over 128.
Okay, now that is not wrong. There's nothing wrong with what you've done here. The only thing is now you've worked with really, really big numbers. Okay, so yes, Mapalo, we're gonna talk about that now. And what you would have to do, Yandi, and Theo as well, because I think you also went this route, is you mustn't forget you have to simplify. Okay, now you've got these big numbers that you need to simplify, and that might take you a while, especially if your teacher doesn't let you use a calculator. If your teacher lets you use a calculator, then it's a little bit easier, but it's going to take you a bit longer. So what Mapalo is suggesting is going to be so much faster for you. And in maths, what we want to try and do is we want to try and do things in the simplest way that we possibly can. All right. Yes, who's asking?
Ma'am, is it fine if we said 7/8 minus 3/16, ma'am? Then we said 8 times 2, and then on top we said 7 times 2, and then we said equals 14/16 minus 3/16, and then we said equals, the final answer is 11/16.
There we go. All right, well done. Okay, so Anel got the same answer. And Jabulo, that was perfect. And that's exactly what Mapalo was suggesting as well. Okay, so Theo, Yandi, if there was anybody else that did it a longer way, this would have been so much easier for you. Okay, and you would have ended up with 14/16. Here, oh, what, that's not supposed to be there. So this is a minus 3/16. And then just as and Jabulo said 14 minus 3 would have left us with 11/16. Good job. Okay, well done, Anel. And then you would have found, Yandi, that if you had divided and divided and divided, you would have eventually got to this anyway. All right. But now, because you used the lowest common denominator, it was just a little bit simpler. How's everybody feeling?
Ma'am, I'm
Good,
great,
ma'am.
ma'am.
Good, ma'am.
Good, ma'am.
Good. Good. I'm
Good,
so
ma'am.
glad to hear that. All right. Now, this is something your teachers at school might teach you how to do this a little bit differently. I'm glad you're all feeling good. But I want to show you how you will be expected to do this at high school, which is obviously where you're going to be in a very short period of time. Okay. I do not want you to add. Yes, Boy J.
Ma'am, may I do it, ma'am?
Yes, tell me what to do. Do you want to tell us what you would write?
Can I?
Ma'am, so wait.
Ma'am,
Just hold on
Ma'am?
1 second. I think Boy J was wanted to say this one. Somebody else can do the next one. It's not a problem. Okay, go for it, Boy J.
No, don't
Ma'am, you see the whole numbers, right?
Mm-hmm.
Yes.
Ma'am, you add those whole numbers first, and then once you get your answer, you start with the fractions. But here's the thing: the denominators are different. So what you do with the first fraction, by 1/3, is that you times the 3 by 4, and the quarter you times by 3, and then you get the denominators will be the same.
Indeed, they would be. Absolutely, they would be. And I think that often when we are at primary school, the method that you are describing now is the one that our teachers teach us to do. Okay. Yes, Yandi, you certainly can. Somebody else want? Yes, Njabulo.
Ma'am, there's a different way that I do it, ma'am, is that we say 1/3, ma'am. You say 3 times 3, and then 1 times 2, 1 plus 2, ma'am. Then you add that section all together, and then you do the same to the left hand side. Then when you get your denominator, ma'am, you have to find the common denominator to make them the same, and then you get your final answer.
Absolutely. Absolutely. And
ma'am?
yes, Yandi.
Ma'am, I kind of have a problem with this number 5, ma'am.
That's okay.
Ma'am, I've been struggling to do this equations like for a long time, since term 2 at my school. But I do get it, but I don't physically understand it.
Okay. All right. Well, I hope that I'll be able to explain it to you today. Okay, so you guys have had some fantastic ideas, and every single one of you that has told me how you would answer this question, all of you are correct. You're just doing it in a slightly different way. And now you wanted to say something?
Yeah, I do mine differently. So I times the numerator. So I times the 3 by the 3 denominator, and then I add the 1.
Good.
And then do the same thing on the left side.
That's
Yes,
quite right.
ma'am.
Now, that method that you are describing, okay, and that Njabulo described, that is what they're going to want you to do next year at high school. So the first thing that you're going to do is that when you have been given mixed numbers, okay, we're going to do what Anel and Njabulo said. We're going to make them into improper fractions. Do you remember we spoke about that in our first lesson on fractions? We spoke about how we would make things improper, and that's exactly what Anel was telling me now. We multiply the denominator with the number in front, so 3 times 3 is 9. Add the numerator, which is 1, and that's where we would end up with 10 over 3. Okay, then Anel and Njabulo said we would do the same thing with this fraction over here, and that's very true. We would say 2 times 4 is 8 plus 1 is 9 over 4. Okay, and then Boy J was perfect when he said that we would have to use a lowest common denominator of 12. Right, so what we would do now is we can see that 3 was got to be a number that's in the 3 times table and a number that's got to be in the 4 times table. So that's why we're using 12. Okay, so now we want to make 10 over 13 into something out of 12, and we want to make 9 out of 4 into something out of 12. So over here, I've got to multiply by 4. Okay, and what I do to the bottom, I've got to do to the top as well. Okay, so that's going to leave me with 40 out of 12. Same thing on this side over here. Let's just use a different color. I've got to times that by 3, so I must times that by 3 as well. Okay, and that's going to leave me with 27 at the top. Okay, and when I add them together in the end, I keep my denominator, I add my numerators, and I'm going to end up with a rather nasty number at the top, but I'm going to get 67 out of 12. Okay, which I can then make a mixed number if I need to. I don't know in primary school if they allow you to leave it like this, but they do at high school. You are allowed to leave it as an improper fraction provided there's no common factors left. Okay, how does that feel? Are you guys ready to try one on your own?
Yes.
Yes, ma'am.
Yes, ma'am.
Okie dokes. Okie dokes.
Yes, ma'am.
Oh, good stuff. Okay, so now I am going to give you one to try. Okay. Okay, you try that one. Try number 6. And I want to see if you can maybe try and do it this way, like the example on the left in number 5, because that's what they're going to expect you to do next year.
Ma'am, must we do it our own way or the example that you did there, ma'am?
In Njabulo, I'm encouraging you to try and do it the way that I did it. If you find that that's too difficult, it's okay. But the reason I'm encouraging you to try and do it this way is because this is what you're going to have to do next year when you get to high school. Okay.
Yes,
so just try. Even if you get it wrong in Njabulo, it doesn't matter. Okay. We can fix everything. Just give it a try. We mustn't be afraid to make mistakes.
Ma'am,
Yes, Tembiso.
I'm in the example of number 5. How did you get to 10? Because I was confused there.
That's fine, Stembiso. Okay. I got to the 10 like this, right? So I'm taking, so everybody else just carry on working, unless of course you want to know the answer to this as well, but you carry on doing your own thing. I'm just talking to Stembiso over here. I'm taking 3 1/3 Stembiso and I'm making it into an improper fraction. Okay, so 3 wholes plus 1/3, and I'm going to write that in thirds. All right. So another way of looking at it is that, well, actually, maybe that, I don't know if that'll help you or it'll just make it more confusing. But if we want to make it into an improper fraction, we've got to multiply the denominator with the whole number in front. So we're taking the 3 at the bottom, and we're multiplying it by the 3 in front, and then we are adding 1. Okay, we're adding the numerator, and we keep that over 3. All right, that's the method. All right, so remember we've got to multiply first according to BODMAS. So 3 times 3 is 9, plus 1 leaves us with 10. That's where the 10 comes from. And then we've got to keep the same denominator. Does that make more sense
Thank you,
now?
ma'am. I now understand. Yes, ma'am,
Perfect,
it
no
does.
problem. Cool.
Ma'am?
All right. So, yes, Njabulo?
Ma'am, the answer that I've got, ma'am, I'm not sure if can I continue the way I'm thinking, ma'am, because I said 2 times 3 plus 1, which is 7 over 2, plus 4 times 2 plus 3 equals 11 over 4, ma'am. So now I see there that you said thing 3 times 4 and then 10 times 4, ma'am. So now I got 2 times 2, ma'am, because 2 times 2 equals 4, and then I'm gonna say 4 times 1 equals 4, ma'am. I don't know if that's fine.
That's perfect. Njabulo, I couldn't do it any better. I've got exactly what you've written down here, and that is perfect. Okay, so you would have ended up with 4 over here, and 7 times 2 would have given you what at the top?
7 times 2 would have given me 14, ma'am.
Good job. Okay, all right. And then Mapalo, I see you've also done it this way. Okay, good job. Okay, and then here, Yandi, did we need to change 11 over 4? Can we keep 11 over 4?
Ma'am?
Okay, so it's like your name's just gone straight out of my head. Njabulo, like Njabulo just said now, we're going to keep 4 over 11 because that's got our lowest common denominator. So he said 4 times 1 over 11 times 1. So that's correct. Okay, and now we're going to keep the denominators. Theo, you said you got 5 as an answer. Okay, let's have a look, Theo. So we're going to keep the 4. We're going to add 14 and 11, and that's going to leave us with 25?
Yes, ma'am.
That's going to leave us with 25. Okay, so if we had 5 at the bottom, Theo, then we could say 25 divided by 4 would give us 5. But unfortunately, 4 doesn't go into 25 a full number of times. So what we would end up doing is we'd end up writing this number as 4 goes into 24 6 times, and there's 1 left over. So that would be 6 1/4. Who got that as an answer? Yes, Theo?
I got 4 and
What did you get, Aisha?
I got 6 1/4.
I said
You got
7
6
over
1/4. Oh, good. Okay. And then Theo, what did you get? Okay, and Anel got that too.
I got 5, ma'am. I said so I got the 2, I times it by 4. Then I got 8. Then I times the 4 again.
Oh, okay. All right. So
please
then,
explain again.
Tumelo, I will with pleasure. Let's do, I tell you what, Tumelo, let me give the other children another question, and then you and I can talk about this one, and anybody who's feeling lost and confused. Now I'm going to make it super difficult, okay? So, well, not super difficult, but a little bit more. Yes.
Ma'am?
Mm-hmm. Yes, Uko?
I got 6 whole and 2 over 8.
Yes, that is correct. But they would expect you to simplify that 2 over 8 to 1 over 4. So that's perfect, Uko. Well done.
Okay,
You're not wrong. Okay, but just remember to simplify the little fraction bit as well. And then you've got full marks. Okay, well done. All right, so anybody that's feeling super, super confident, I'm going to give you another one to try. Okay, I'm going to make this. Yes, Njabulo?
Ma'am, sorry, ma'am, to disturb, ma'am.
No, that's why we're here.
Ma'am, 6 and 1/4, ma'am. Will they want you to simplify it more, as in further than 6 over 4?
Yes, they
1/4.
would. Yes, so you can't leave 6 over 4. So in other words, somebody else was asking, was it Theo? I can't remember now. Somebody said that they had their answer as this, as 6 and 2 over 8. So now this is the bit that they would expect you to simplify. Okay,
No,
so they
ma'am.
would expect you.
No, ma'am, I'm saying, as in, let's say, see, the answer that we have here, ma'am, 6 1/4. Will they
Yes.
expect you to simplify that one in a more, as in, make it a fraction?
No, because you see, the only thing that you can do, what we did is we ended up with 25 over 4, and that's where the 6 1/4 came from. So when you get to high school, now you've got to just do what your teacher tells you to at school, okay? But at high school, you can actually stop at this step over here. So you can stop at 25 over 4, but maybe at primary school, they expect you to take the improper fraction and make it into a mixed number. But if you did this at high school, if you do that next year, your teachers will mark that correct, just like that. I think it's only at primary school that they make you do it as a mixed number again.
Yes, ma'am.
Okay, but no, you can't simplify that anymore. As it is there, the 6 1/4 is its most simplified form. And actually 25 over 4 is also simplified. What's not okay? What's not okay is if you get something like this. Let's say you get 18 over 15. Then that's not okay. You can't leave that because 18 and 15 are both in the 3 times table. Okay, so you've got to divide that by 3 and get 6, divide that by 3 and get 5. It's still improper, but this is okay. This is accepted, all right, because it's in its most simplest form, right? What they do in primary school for some reason is they just expect you to go one step further and say, how many times does 5 go into 6? It goes in there. Once what's left over? 1, and then we're going to put that over 5. But at high school, you can stop there. Okay. All right. So let's try number 7. Let's try the challenge question and let's see how we get on with that. Oh, you're done, Anel. Okay. All right. So, Anel, in the meantime, try number 8. You're struggling, Yandi. That's fine. Okay. So, Yandi, let's do this together. Okay. We want to make 5 and 2 over 7 into an improper fraction. So, how am I going to make 5 and 2 over 7 improper? Can you tell me what we should do?
Ma'am, I think you should multiply.
Multiply what and what together?
Multiply 5 and 2.
5 and 7. Multiply 5 and 7. So what's 7 times 5, Yandi?
35.
Good. Plus 2 leaves us with?
Plus 2.
Yes, plus 2 leaves us with?
37.
Good. So I've got 37 over 7. Okay. Now we're going to do the same thing on this side. So which 2 numbers are you going to apply together, Yandi?
2 and 4.
Good. So 2 times 4 is?
8.
Excellent. It's 8. All right. And then what you're going to do with the one on the top, Yandi?
Adding.
Good. So what are you going to end up with over here?
9 over 7.
9 over?
4.
That's it. Okay. Well done. That's perfect. right? And now you're going to look at this and you're going to say to yourself, you're adding together two fractions with different denominators. So now you've got to pick a number that is in the 7 times table and that's in the 4 times table. What number are we going to use? It has to be in both times tables.
And
Well
the
done,
opposite
Anel.
number.
Ma'am, can
I
you use 3?
I'm sorry, I didn't hear that.
28.
Esther, what did you say?
May please repeat what you said?
28.
Okay, that's fine. So I'm trying to find my lowest common denominator. So I've got 37 over 7 and 9 over 4. That's fine, stem B, so not a problem. What number is going to be my LCD? What number am I going to write at the bottom? You say 28? Good, well done, 28. That's lovely. Okay, and then this one's going to be, see, this is why our times tables are so important. Okay, because if you know your times tables, then you know 7 times 4 straight away is going to leave you with 28. Okay, so please, I know it sounds like a pain when somebody begs you, but the more you learn things for yourself, like your times tables and bonds and things like that, it just means you can work so much faster. Okay, so now we've got to multiply that by 4, which means we've got to multiply that by 4. So 37 times 4 is going to leave us with, so 7 times 4 is, and then that would be 12, 13. Is it 148? Is that right? Okay, good. Well done. It's 148. And then here we've got to times that by 7 as well. And we've got to times that by 7. What's 9 times 7?
27.
60? 63. Good job. Okay, well done, grade 7s. This was a really, really difficult one. Okay, so now we're going to
add.
Exactly. Okay, so we're going to keep the 28 at the bottom. We've got to add 148 and 63, and that's going to leave us with
210.
211.
211 indeed. Okay, so 211 out of 28, and then I suppose we could make that into a mixed number, but I don't think that there are any common fractions. How did that go? Was that really, really difficult, or was that okay?
Okay, ma'am.
Okay, ma'am.
Understandable.
Oh, good. I'm so glad, because I wanted to give you a bit of a challenge as well, but I didn't want to make it so that it was so difficult that you weren't able to do it. I know that our time is sort of running out here, but just very quickly before I give you back to Elzon, I know that Anel managed to do question number 8. Has anybody else managed to do question 8?
No, ma'am.
No, that's okay.
Ooh.
What do you think you should do here, Njibulo?
Ma'am,
Based on
4
the
times-
discussions we've had tonight, what would you do?
4 times, add the first thing, the first operation, and as in 4 times 2 plus 1.
Mm-hmm.
And then 4 times 2 is 8 plus 1 equals 9 over 4.
Beautiful.
And then minus 3 times 3 equals 9 plus 1 equals 10 over 3.
Excellent. Excellent. All right. And then what is our lowest common denominator going to be? Let me see who I haven't asked a question of this evening. Hang on a second.
3.
Who wants to talk?
12.
12, right, Tumelo, perfect. Okay, so Yandi, you got the same answer. It would be 12 here. This would be our lowest common denominator. So we're going to times this by 3. We've got to times this number by 3. That's going to leave us with 3 times 9 is?
27.
27 over 12. Good. Well done, grade 7s. And then times that by 4 and times that by 4. Yes, is that a question? Okay, and now imagine this, we're going to end up with a negative answer. Have you done things with negatives in them?
Yes, ma'am.
Yes, ma'am.
Oh,
Yes,
you
ma'am.
have. Oh, okay.
No,
All right.
ma'am.
So if we're sitting, okay. So if you have, or that's great. If you haven't, don't worry. I'm sure your teachers will still do that with you. Let's just finish this off together. So we're going to keep the 12. And now we've got to say 27 minus 40. What number would we end up with then?
-13.
Indeed. Well done. Good job. Sure, you guys have done some really, really difficult questions tonight. I'm very, very impressed. Well done. Give yourselves a big hand of applause. There we go. Good job, grade 7s. Okay, I'm going to hand you back to Elzan now. Elzan?
Oh, yes. Sorry, I didn't mute myself.
Okay, no
unmute
problem.
myself. Thank you so much, Lee. And well done. A hand clap from me as well to you guys. You guys did awesome tonight. Did you enjoy this class?
Yes, ma'am.
Yes, ma'am.
Yes,
Good.
ma'am.
That's
Yes,
great to hear,
ma'am.
guys. I'm so happy to hear that. And I quickly just want to share before we say goodbye, our revision. So did you guys manage to find the dividing fractions last Tuesday, or this Tuesday, sorry? You can just say yes or no.
No, ma'am.
No, ma'am.
No.
You didn't. Did you go have a look, or do you still need to go have a look?
Still need to go have a look, ma'am.
Still need to go have a look. Okay, awesome. Well, after today's class of adding and subtracting fractions, we are gonna go to the Watobi app. Oh, sorry, moving ahead into common fractions. And then afterwards, you will find add and subtract fractions. And underneath there, you will see a tab that's called subtracting fractions with unlike denominators. Okay, so you can make a note of this, take a screenshot or write it down quickly. You can just let me know when you're finished. And then this is your revision before our next class on Tuesday.
Elzan, in fact, if you've got time, and I know time is always difficult for us, and I've just made that suggestion, but you could actually try any of the things here. So adding fractions with like denominators would be easier.
Bye.
Bye, Baja. Adding fractions with unlike denominators would be a little bit more difficult, but you should also try the add and subtract mixed numbers, and there's even a quiz down there for you to practice before we have our test at the end. So yeah, if you've got time, then all of these would be suitable for you. Okay. Sorry, Elsa.
Exactly. No. And I think it's also good to remember, not only will your names be on the leaderboard, the more lessons you do, the easier your name will be on the leaderboard. Maybe you'll be number 1, who knows? But this isn't a competition at the end. This is for yourself. So the more you practice, the easier this will get for you, or this will be for you, and the more confident you will be in doing fractions as well. Okay. So challenge yourself, do as much as you can, and yeah, then next Tuesday we'll see you again. Okay, guys, well, that's all from me. So nice seeing you all again, and I just love seeing you guys participate so well with Lee.
Yes, you do. Thank you so much. I know it makes the lesson so nice for me as well. You're definitely my favorites.